Hello and a very warm welcome to all the viewers today. In this episode, we are joined by Eric McLaughlin, who is the Vice President of the Client Computing Group and the General Manager of the Wireless Solutions Group at Intel. He has over 22 years experience at Intel, and he has been instrumental in driving wireless innovation, focusing on various technologies in the space like Wi-Fi and Bluetooth and several others I'll be talking about. He is indeed a veteran of the Wi-Fi industry, and he has played a crucial role in shaping Intel's wireless strategy. Eric is a graduate of the Brigham Young University and is passionate about delivering seamless wireless experiences. So, in today's episode, we'll dive into the world of wireless technology with Eric McLaughlin. Eric, a very warm welcome to our show.
Thank you, Arun. It's great to be here. Excited to have this conversation.
Excellent. So, Eric, let's get things kicked off now. So, give our viewers a high-level, maybe a couple of minutes overview of the evolution of Wi-Fi technology. We all use Wi-Fi, but it'll be helpful it comes directly from you. What key milestones have brought us to where we are today, and why is it still important in today's hyper-connected world?
Sure, glad to. So, Wi-Fi actually started in 1999, and initially it supported only about 80 megahertz of spectrum, so 20 megahertz channels in the 2.4 gigabits band, and delivered about 11 megabits per second speed. Obviously, at that speed, you're basically doing email, some light web surfing, stuff like that. Intel's first foray into Wi-Fi in a big way was in 2003, where we launched our Intel Centrino platform, which was a full, that any Centrino product came with Wi-Fi integrated into the system. That accelerated connectivity of Wi-Fi 1, Wi-Fi 2, and Wi-Fi 3 that supported up to about 54 megabits per second and larger bands, including the addition of the 5 gigahertz band. So now you had two bands, 2.4 and 5. In the years that followed that, more generations came. Wi-Fi 4, Wi-Fi 5 in particular, added different bandwidths, added multiple antenna technologies, and essentially were really the time when the number of devices that were implementing Wi-Fi as their main radio solution exploded. Wi-Fi 6 was a really pivotal year. That's when Wi-Fi went from a contention-based network, which means all of the stations were saying, hey, I'm ready, listen to me, pick me, and the AP would respond to those requests. The Wi-Fi 6 was when we moved to OFDMA, which is a more managed network where it actually was managed in a way that traffic is prioritized and stations are told when to transmit, when not, etc., which actually improves the efficiency of the network as well as the capacity of the network by doing that. So Wi-Fi 6 was big. 6E came along, and the world added up to 1,200 megahertz of new spectrum in the 6 gigahertz band. Not every geo uses the same exact amount of spectrum. The US opened all 1,200 megahertz for unlicensed use. Other geos opened smaller aspects, the lower parts or the upper parts, etc. And some, like China, didn't open any of that 6 gigahertz spectrum to date. And then now we're shipping Wi-Fi 7, which leverages all of the OFDMA characteristics of Wi-Fi 6, the new spectrum in 6E, and implemented capabilities like MLO to improve efficiency of the network and speed and range of that network, and multi-RU puncturing, which utilizes all of the channel bandwidths and is able to split some of those bandwidths to be used in various applications. So when you get 320 megahertz channels, 4K QAM, you get very high performance up to 5.8 gigabits per second. To put that in context, if when I travel from where I live in Oregon to the East Coast, which I did last week, it's about a 5-hour drive. In 5-hour flight. If we're using Wi-Fi 1 at 11, correlating that to 11 megabits per second, It takes about 5 hours to get there today, right? So if that's your baseline, Wi-Fi has increased in speed 500 times in that transition from Wi-Fi 1 to Wi-Fi 7. We would get to the East Coast from Oregon in 40 seconds if we were using that same metric. So pretty cool advances in Wi-Fi over time, not just speeds and feeds, but also new spectrum, multiple times new spectrum, new channels, new channel bandwidths, and in particular, better and more efficient management and utilization of all the available bandwidth.
Wow, Eric, that was such a impressive history in such a short amount of time. I've never heard somebody say that, and in such beautifully, right? So thank you for doing that. And I like the analogy that you gave, right, from 5 hours to like 47 seconds, and that's amazing. That's amazing. That shows the advancements in technology that have taken place. And thanks to your leadership for enabling that.
Oh, sure. Yeah, it
Yeah,
takes a village.
yeah, it takes a village, and can't imagine life without Wi-Fi.
Agreed.
Yeah. So, Eric, talk to our viewers about, we heard about the Intel Connectivity Analytics program, right? So how does it really help, wireless solution providers, and what unique aspect does it bring altogether?
Sure. It's an area we're really excited about. It's so kind of the brief explanation is, if you think about where connectivity sits on any device, right? If it's a phone, a PC, etc., connectivity is on the edge of the platform. It's the first place data comes in. It's the last place data comes out. So the ability of our solution, our Wi-Fi or Bluetooth solutions, or even our Thunderbolt and Ethernet solutions today, is that they have a view of what's happening at the network as well as the platform that isn't visible to a network provider, to a DEX provider, or to a OSV even, because we sit in a very unique place. So essentially what we're doing with Intel Connectivity Analytics is two phases. Phase one is we can provide a lot of raw data, probably 300 fields of different types of data right around the applications being used, the pipes that are available, the history of the performance of those pipes, the number of APs that are visible, the number of APs that you're able to connect to, how loaded are those APs, what size pipe do you have coming into the home or to the office, or how much bandwidth is being allocated to the system, and how is all that stuff working together. So we have over 300 fields of unique data that we have access to. Phase two is generating insights out of that data, learning from that data, and providing insights to our customers that allow them to quickly take that data and use it in the most beneficial way. So let me give you an example, and this is a real world example. We deployed this capability in conjunction with Cisco Gear, the Riverbed Eternity DEX solution at Intel IT. They put it on thousands of machines across Intel and tested it for 6 months. They've actually published a white paper, and I'll send you the link you can include when you post the podcast. But they were so impressed because what they were able to do is take connectivity issues that happen every day, right? There's no perfect network, there's no perfect client, whether you're at home, in the office or enterprise, at the airport, at the hotel, conference room, etc. There's always going to be problems. It's just the nature of wireless technologies. And what we're able to do is, and what Intel IT said, is things that used to take us 20 minutes to diagnose. For example, the driver needs to be updated, take us 20 seconds now, because we get data and analytics that tell us, hey, you should look at the driver. There's probably a driver problem. In addition to that, we're also doing AP placement type things, right? We're able to say, this device was here in the building now it's here. Things have changed. What changed? Same AP, too long a distance, didn't switch fast enough. Maybe that's one thing. But even more important to the IT department is move to a location, there's really no good AP in that location, you probably need to update your layout and give it, put a new AP in. So those things took days to diagnose. Those are being done in minutes. So that's the value that this kind of analytics and insights are providing. And we're just at the tip of the iceberg, right? We're just at the very early stages of deploying this with multiple partners. And we see, our goal, quite frankly, and the goal of the people that we're working with is to move from, hey, you have a problem, you should fix it, to we fixed it. And so remediation is the goal. And so our hope is that as a user of the technology, right, people trying to get their job done every day at work or home or wherever they may be working, they may experience a problem, but within a couple minutes, without any intervention or a call to the help desk, it gets resolved, and they're back up and running in a great way. So that's what we think the power of ICA is, and it's only going to get better as we do more.
Yeah, that's impressive. From 20 minutes to 20 seconds, one, and two, the other thing I took away was it all happens by itself, right? Like magical for a user. I probably would not even know that there is a problem. And that's where the power of ML and AI comes in with all the data that you're able to gather.
Correct.
Yeah. So talking about that, Eric, let's talk a little bit about the AI by itself. You have mentioned multiple times in various conferences, forums, that in order to get AI performance on PC, Wi-Fi is very critical, right? So talk to our viewers about that. What are the interlinkages between having an excellent Wi-Fi and the AI performance on PCs?
Sure. Yeah, I think there's two layers of how Wi-Fi and AI intersect. One is there's a lot of different type of AI workloads that are being thrown at AI today, right? You've got short, bursty, got to get this quick type workloads, many of which are done on the client, right? Intel's AI PC, for example, with our combination of CPU, GPU, and NPU that allow 40 tops or better that give a place to do large language model work. You need to get the data from the query or the data from wherever it is to the client so that workload can happen. So you need that transport layer, which is typically Wi-Fi, to do that with the right speed and determinism, so that it happens in the right amount of time, so that you get accurate information to and from the user. The other workloads aren't all going to be done on client, right? You've got edge workloads, you've got cloud workloads, and that's where Wi-Fi transit becomes even more important, because now you've got a longer transit time, right? You've got a longer distance for the data to go, the query to go, and the information to come back, the answers to come back. I was thinking the other day how before assistants like Alexa or Google or Siri, I downloaded this app, and I wish I could remember the name of that app on my phone. And I remember asking it to do stuff for me, and I was fine that it took seconds, right, to understand what it was I said, to come back with some sort of response, and it wasn't fast, but it was kind of cool. I'm at the point now where if I'm asking an AI type inference, question or need a quick response, right? I want to see a picture of myself on a beach with a picnic basket, or take this photo and edit it to that, or write this email for me. I'm not comfortable waiting 10 seconds, 20 seconds, 30 seconds. I feel antsy. There's something wrong, right? So Wi-Fi is that transport mechanism that's primarily going to be used to get the information to and from the cloud, for example. And again, it has to be timely in order to ensure accuracy. If you're only getting the data in spurts and not at the right times, you have some potential accuracy problems with the response. So that's part of how Wi-Fi is going to help drive the AI work forward, is by being that reliable, predictable transport mechanism that gets the right data to the right place, or from the from the right place to the user, in order to enable an accurate, timely response. One of the other ways that I see Wi-Fi intersecting with AI is we can use AI to enhance the Wi-Fi experience. We just talked about Intel connectivity analytics. As you rightly pointed out, in order for this to take that next step and get to remediation, AI is involved, right? And our partners are using that. You're able to take that data, take those insights, put it into a learning model, build that model, and then over time, it's going to get smarter and smarter, and the accuracy as well as the time it takes to get your responses back are going to be much faster. And that's going to enhance your overall Wi-Fi experience, right? But it even goes beyond that. And I can give you a couple examples. We're looking at and using, for example, AI to do some smart AP selection. So most people don't know that clients make a lot of the decisions in a network on how or what they're connected to and how they're transmitting. It's primarily because the client knows what it wants to do before the AP would know what it wants to do, right? So in the Wi-Fi standard, clients have certain thresholds that they reach before they actually decide, I need to roam to a different or better AP. We're actually using, in our solution called Intel Connectivity Performance Suite, a AI algorithm that allows it to learn what access points am I able to, to connect to on this network? Am I authorized to connect to on this network? Which ones have a history of performing well? Which ones have X number of users? We have 20 or 25 scoring things that we do simultaneously, and we actually proactively move without user knowing or needing to worry about it to a better AP. And that works great in an enterprise, it works great in a home mesh network, it works great in a hotel or a conference room where multiple APs are visible. So that's another way that we use AI with Wi-Fi. And it's not only Wi-Fi, we have use cases with Bluetooth, we have use cases with Thunderbolt. We're actually using AI on network attached storage solutions that allow them to sort your photos instantly, right? And you have all this stuff in a massive storage box, and you can find the photo you want in seconds. So those are the kind of ways that we're seeing AI either over Wi-Fi or influencing Wi-Fi to actually deliver better experience and predictable results.
Yeah, those are beautiful use cases, Eric. Eric, so let's take a step back and maybe a broad question in terms of PC connectivity by itself, right? What are some of the challenges that you see in the PC connectivity world, and how is Intel addressing them?
Sure. I think the first thing I would say is you mentioned earlier, I think the ubiquity, right, of Wi-Fi. That's a great thing for connectivity, but it also means that there's a lot of things connecting. In the world today, the average number of devices in a home that are connected simultaneous to Wi-Fi is 18. And that's a worldwide number, right? There's probably certain parts of the world, geos, where Wi-Fi isn't as prevalent. Western Europe, for example, Wi-Fi isn't as it's there, but cellular is cheap and it's more frequently used for certain types of connectivity. So maybe the device is connected to Wi-Fi in certain parts of the world, maybe fewer than 18. But to get to an 18 average, that means there's a lot of places that are more. My house, with 3 people in it, 21 devices, including my sprinkler system, my oven, and all of the other devices that are in there. And I don't even have what you would consider a smart home. I'm not using it for lights and door locks. I do have a Ring camera, right? And those kind of things. But I have 21 devices in my home. And if all my kids and their husbands and wives are over, we have like 30-something devices. So it's part part of the reason for the evolution of Wi-Fi is not just the ubiquity of locations where it's at, but the demands and workloads that are being placed upon Wi-Fi by having so many devices expect and need to be simultaneously connected. And as you said a minute ago, I can't imagine a day without Wi-Fi. I tell the story that when my kids were younger, they used to bring friends over, and friends would say, "Where's the refrigerator? I'm hungry," right? Or "I want a drink." Now they're like, "What's your Wi-Fi password?" So, it's I think, well, actually, I heard someone say at Cable Lab's event last week that their power went out, and the kids were totally understandable that the lights were off. They could not fathom that Wi-Fi was down. They couldn't understand why is Wi-Fi down. Right? And so all of the efforts in the Wi-Fi industry are all about understanding that not only do we have ubiquity, but we have heavy workloads. And more of those are coming, right? AI will drive more workloads. AR, VR will drive more workloads. Those things are going to be commonplace, typical things that we do day to day in our lives as we move forward. And you need a transport and connectivity technology is built for that kind of situation. And that's where Wi-Fi is, and that's where Wi-Fi is going as we move forward.
Yeah, and Eric, that's a perfect segue to talk about the next segment, which is the future round. So beyond 2025, looking beyond, let's say, 5-10 years, where do you see, what are some of the trends that you see in future in terms of Wi-Fi, especially with all 6E coming in, 6G coming in? Where do you see the key trends to be?
Yeah, so I think the first one we're starting to see now is sensing. So when you have a Wi-Fi solution in pretty much every device that you have, and especially as the channels get wider, you end up with essentially a radar capability, right, with the way that frequency can be used. So an early implementation is one that we've done on the PC. My PC is enabled with walk-away lock. I don't have to connect my phone to my PC or anything. It just knows that there's a human in front of it, and it doesn't need the camera on to do that. If you turn the camera on, right, you drive a power problem. So Wi-Fi is always there. It's always trying to connect, and we can run it in low power. And in that, it can determine there's a human in front of the device. When it determines the human's in front of the device, it opens up the lock screen, and you're able to type in your password and get going. When I leave, it senses that presence is gone. It locks the platform if I haven't done it already. So really simple security, capability enabled through wireless sensing. That's going to get bigger and better as things move forward. And what I mean by that is, right now we have proximity detection or presence detection. We're going to get to breathing detection. We're going to get to a place where we have gesture control. So the way you interact with your devices, whether it's a phone or a PC or whatever, are going to change as we move forward through this ability to sense not just presence, but multiple presences, right? So good example. Imagine a future conference room. Through Wi-Fi, it knows there are 18 people in that room, and it knows who's in front of their PC, who's not in front of their PC, knows that they're actually looking at the PC or not looking at the PC. And there's interaction things that can happen and changes that can happen dynamically in that engagement because all of that information is there. So sensing is going to be a big deal. We imagine healthcare usages, right? Breathing stops, 911 triggered, those kind of things. People fall down, right? And I know I tell the story on myself. I was lifting a super heavy thing the other day, and I was out in the yard with my son. I realized that I was about to trip because there was some uneven ground. So I tossed the heavy thing off my back and fell on the ground. And my watch goes, "We see you fell." right? Are you okay? Um, that kind of thing might happen in front of your PC, right? Somebody's in bad health, something happens. We know that they fell. We know that something, bad happened. We can trigger an event. So sensing is a big one. The next element of sensing is being contextually aware. So it's a next level capability within sensing where, for example, I've got a headset on right now that's Bluetooth connected. With sensing capabilities, I should be able to know not just that I have a headset connected with Bluetooth, but I should know what capabilities this headset has, right? And how can I interact from my PC device to my headset with this particular headset as opposed to some other headset I might have? So having not just the sensing piece, but the context piece is going to, again, elevate and change the way users interact with their devices. And Wi-Fi is going to be inherent in that. It's not just, you don't need all of, you don't need cameras on all the time, although the combination of a camera and Wi-Fi, the really powerful sensing capabilities, right? And I think we'll see some of those use cases, some use cases be driven by the contextual awareness of both technologies simultaneously. And we'll use things like Bluetooth to do, we're already doing hearing aid connections, right? So on your PC, you can use your hearing aids as your headphones. I think we'll get some additional context that we can use to determine, is the person hearing? Are they interacting? Is it beneficial? Do we need to turn the volume up? What do we need to do? So I think sensing is one of the big things, and contextual awareness is the next big thing that will really take the Wi-Fi that we use for access and use it now for other things because of the ubiquity and the capability of those solutions.
Wow, that's very fascinating. It almost sounds like a sci-fi, but yeah, it's all coming. Eric. Eric, so you spoke earlier about a couple of AI use cases that are here and now. So talk to our viewers about some of the AI ML use cases, both from a futuristic standpoint, something that are being in the roadmap or being planned in the roadmap.
Sure. One of the things we're working on, on the PC side, PC is your primary communication device these days. It's interesting since COVID in particular that I take more calls on my PC today than I do on my phone by far. And most people are like that. I've not had anyone debate me on that. Once they think about it, they're like, yeah, I had 12 Zoom calls today, And so, it's a very, it's the device you interact with most is your communication device. So one of the challenges that we all have, everyone's using a different thing, right? Some people have this great, podcaster setup at home. Some people like me are using this Bluetooth headset. Some people just use the PC mic as speakers or the speakers in their monitor or whatever. So quality of that of that conversation isn't always great, right? You have network connection problems, you have device connection problems, you have fidelity problems just in whatever device you might be using, and they're all different capabilities. So we're working on a capability that uses AI to actually filter out all of the non-essential stuff. And regardless of the devices that you're using to talk and to hear, we can improve the quality of that experience. And so we kind of factor out all of the stuff that shouldn't be part of the conversation, if you will, and try to factor out the difference in capabilities between your devices and my devices. And by doing that, we can enhance and elevate the audio experience to a place where you always hear what you need to hear, and they always hear you. So that's one of the things we're working on, that's not just in the labs, it's starting to go into, some POCs and those kind of things that we're working on and working to get it towards production. There's I think a lot more that we can do. As I mentioned in ICA, there's a lot more we can do with AI. I can tell you what one of our partners is working on. It's a pre-announced product, so I can't tell you which partner, but they've actually taken our Intel connectivity analytics, as well as the information that they get out of their infrastructure equipment. They've created their own large language model, and they've built their own chatbot, chat GPT type interface, and they can query all of that, plus all of the documentation that they have for their equipment and networking in general, and provide amazing answers to an IT person, right? If you're an IT admin, and we tested this real time a couple of weeks ago when I was visiting them, we came up with an ad hoc query on the spot. We said, tell me all of the roaming events that have happened in the last 4 hours. And the thing within seconds spit out, a list. Here's 10 roaming events that happened. Then we thought about it a little bit, and again, nobody planned this, right? It was just ad hoc. It was actually our engineering GM. He said, how many bad roaming events were there in that 10? And they graphed them. It graphed the roaming events, and it said, these ones we would consider bad. These were roams that shouldn't have happened, or happened at the wrong time or for the wrong reason. These were fine, right? These were appropriate. And everyone in the room, including the customer who'd built all this stuff, was kind of shocked, right? That they actually got information that they hadn't even thought of. They hadn't planned in a question, give me the roaming events, but it was there because they built that language model, right, with all the information, and it was smart enough to figure out and decide. It had the documentation, it had the infrastructure side, it had the client side. It was like, hey, I would say these are for bad reasons. So it's those kind of things that are being worked on right now by us and our partners, all of which is going to just continue to enhance not just the speeds and feeds that you get with Wi-Fi, or not the predictability of it, but actually the user experience of it.
Yeah, no, you're right. I mean, eventually it's about the user experience, and all these technologies have a huge role to play. Like the example that you just gave, the user experience is significantly boosted with all these. Awesome. Eric, that brings us toward the third segment of our show, which is the rapid fire round. So here's my first question to you. Wi-Fi 6 or Wi-Fi 7? What excites you more and why?
So Wi-Fi 7, because it includes Wi-Fi 6. So Wi-Fi 7 takes all of Wi-Fi 6, all of Wi-Fi 6E, and then builds upon it with things like MLO to improve throughput and speeds and latencies and distance, range, and then with things like multi-RU, which actually makes best and most efficient usage of the channels that you're actually connected to and using. So Wi-Fi 7, in the testing we're doing, there's some testing coming up between Intel and Cable Labs and a few others that demonstrates that even on a legacy AP, Wi-Fi 7 performs better in a real world environment. This testing is done in a house, in a neighborhood, not in a lab someplace with a screen room and everything. So I think Wi-Fi 7 is incredible technology and takes all of the things that we've done in the industry over time and makes incredible use of them.
Wow, wonderful. The second one, what is the one Wi-Fi feature you wish more people knew about?
I wish more people knew about and really understood the amazing opportunity the wireless industry was given when we got 6 gigahertz spectrum. If you think about it, it's more spectrum than you have in 2.4 and 5 gigahertz combined. It's free of incumbents, right? So you're not getting interference from your microwave or your DECT phone or anything else that happens to be going on. It's free spectrum of interferers, and it's a massive amount of spectrum. And I see it's hotly contested, right? Because of course the cellular, folks want new spectrum and need new spectrum, so it's a hotly contested place. But for the places that are opening it up, which is most places in the world are opening part or all of that spectrum, I wish people really understood and ran out and upgraded their AP and their network, because that spectrum alone is going to provide better experience than they've ever had on Wi-Fi. So to me, that's the message I try to get people to understand in the conferences I'm going to, the places I'm speaking, is that do not look away from 6 gigahertz. It's the most important thing that's happened in Wi-Fi in the 22 years I've been working in it.
Yeah, no, that's great, because hopefully through this channel as well, a lot of people would get to know about it. Wonderful.
Great.
The third one, in one word, describe the future of wireless connectivity.
Magical. I think I tease. I'm responsible for the wired connectivity as well as wireless connectivity, and Intel. So I tease the wired guys that you guys do amazing stuff. Thunderbolt at 80 gigabits per second, right? It's amazing stuff. But you need a wire. We do this without it, right? It's magical. Yeah. But I think the reason I use magical is I really feel like the experience that's going to get delivered via Wi-Fi to users. And by the way, 80% of cellular data traffic runs over Wi-Fi. 90% of the world's internet traffic runs over Wi-Fi. It's been an evolution to get to this place. But with Wi-Fi 7 and beyond, we're delivering a magical experience for the people that are using it. It should be, over time, free of worry. It connects, it stays connected. It's connected at high rate of speed. We had some reviewers looking at some of the Intel's new Lunar Lake laptops, our Core Ultra 2 AI PCs with Wi-Fi 7. First comment back from the reviewers was like, holy cow, Wi-Fi 7 is blazing fast, over 1 gigabit per second throughout my home, Bluetooth connected, stayed connected. I love this stuff. So that's where we're headed, from crap, my Wi-Fi's down, to this is an amazing experience, a magical experience.
I can't agree more with you on that one. The fourth one, what is the most unexpected use of Wi-Fi technology that you have ever encountered?
That's a good question. I think the first time I saw sensing was probably that moment for me where I was like, what? Because in my head for so many years it was just, that's how you connect to the internet, right? That's how you connect to your internet. And I walked into a lab and they were like, hey, we got to show you this cool new thing we can do. And this was probably 5 years ago, and they showed me presence detection and device detection through sensing. And I was just blown away, right? That how does this work? And started to get into the details. So to me, that was probably the one moment where I was like, Wi-Fi is so much more than just access. I'd say device-wise, like the biggest surprise I ever had was when we implemented our sprinkler system for our house. We have an acre of land that my wife gardens, and when we put it in the sprinkler system, it was Wi-Fi enabled so that she can turn the sprinklers on and off wherever we're at in the world. And I was like, who would have thought, right, that your sprinkler system needed to be Wi-Fi enabled? But she uses it all the time, so it's that was probably the biggest surprise of the use case, to have your Wi-Fi connected to a sprinkler system.
Yeah, Eric, that is so right, because there are so many devices in the house. Now that you say it and I think about it, there's just in my own house so many devices. We didn't even think that was all magical, right? Just because of Wi-Fi. But yeah, next time I'm going to look at any of these devices, I'm going to thank you and the team at Intel for all the wonderful things that you guys do for Wi-Fi. Already, the last one I have, that if you could instantly solve one challenge in wireless technology, what would it be?
That's a good one. I guess, I'd go back to my 6 gigahertz comment, and I'd say get every country, every FCC or CTIA or all of the regulatory bodies and agencies in the world to just enable 6 gigahertz. I really think it's it's the foundation of delivering that magical experience everywhere people are at, whether you're in a home, an office, or a venue. And so, if I could just get everybody to understand, even the, I work a lot with cellular companies, carriers, everything, and well, the discussion I always want to have is we're way better together than we are fighting. So. And you need Wi-Fi. You offload to Wi-Fi all the time, right? 80% of your traffic runs over it. So let's work together, and 6 gigahertz should be the place we do that, because we can take on more of that offload. We can do more things with that spectrum. So that would be the problem that I would solve. So drop the arguments. Let's just enable it, and let's get going and using this precious commodity to deliver those magical experiences wherever I'm out in the world.
All right. So any viewers who are listening in, I just want to underline what Eric just said. 6 gigahertz, that's the way to go. Excellent. Eric, that brings us toward the end of this wonderful and very insightful show. Thank you so much for your time.
Arun, thanks for having me, and thanks for the insightful questions. It was fun.
Awesome. Thank you.